Hello and welcome back to IXL tutorials. This is Mr. Duffick, and I thought I would go back to IXL R8 and R9 to complete these problems in sort of a different way. This year with our geometry team, we decided to push special right triangles to after the trig ratios. And so in the other videos, I was using special right triangles partially to solve these problems. And I thought it would be a great idea to actually redo R8 and R9. So we were using more of the traditional method to find our solutions. Okay? And so I'm going to spend today probably doing just a problem because it takes a little bit of time to explain to outline how to solve R9. Okay? So I'm going to go ahead and jump to, let's see, to my snipping tool as usual. There we go. All right, let's do this. Okay, so in R8, we had problems where we had right triangles and we were trying to find a missing side length, right? Well, R9 is the opposite. We have a couple of side lengths and now we want to find a missing angle, and of course we're going to be doing this using trig ratios. And so first thing is first, we should always get into the habit of writing SOHCAHTOA up top. SOHCAHTOA up top. Okay, and then after that, we just want to highlight the pieces of information that we need to reference. So this question is specifically asking us to find the measure for angle U. And so angle U is where I will put my theta, my Greek symbol. Okay, just as a way to know we are going to be referencing U for the rest of the problem. Now, what side lengths can we use to help us solve our problem? Well, we know side UW has a length of 16, so we'll definitely use that. And we know side UV has a length of 8 square root of 3, so we'll definitely use that. We're using these two because we actually know the side lengths, and so we can actually take those numbers and use them to calculate our missing angle here, theta. All right, so from here, we just figure out the how we want to label the sides, either opposite, adjacent, or hypotenuse. We know that UW, or the length of 16, is opposite from our 90 degree, meaning that is automatically going to be the hypotenuse. Okay. We know VW, the one we did not highlight, is opposite from or not touching theta at all. So this one's opposite. Sorry. And lastly, 8 square root of 3, or side UV, is adjacent or touching or next to theta, and so this is adjacent, since adjacent just means next to, touching. Okay. Now from here, we see that the sides that we highlighted are adjacent and hypotenuse. And so we want to choose the correct trig function that uses adjacent and hypotenuse. And we look at SOHCAHTOA and we scan it. And so which one has an A and an H in it? And that, of course, is going to be cosine. It's not going to be sine or tangent, but it's going to be cosine. Cosine is adjacent over hypotenuse. And so that's what we're going to write. Cosine of theta equals adjacent over hypotenuse, like this. Okay, go ahead and plug everything in. We'll have cosine of theta. Theta is angle U, so I'm going to go ahead and just write U degrees, equals the adjacent side is 8 square root of 3 all over the hypotenuse, which is 16. Okay, and from here, it's nice, we can actually simplify 8 over 16 down to 1 over 2, or 1/2, right? 8 is just 1/2 of 16. So this becomes 1 times square root of 3 over 2. Or, since 1 times anything is itself, really this becomes just the square root of 3 over 2. And so really we have cosine of U degrees equals the square root of 3 over 2. And so from here, we have to figure out what the degree value is for U, right? What angle that is. And to do that, we're going to use what is called arc cosine. And it's spelled one of two ways, or written out one of two ways. So you can do sine of -1, or not sine, cosine of -1, kind of like that. or you can write it out as arc cosine, right? And so the arc cosine is going to cancel out with the cosine, but it's kind of like multiplication. You know, if we got to do one, if we're going to do it to one side, we have to do it to the other. So if we're going to add an arc cosine to the left, we're going to add one to the right as well. Okay. Now the arc cosine and the cosine are going to cancel out, so we are left with u degrees equals arc cosine of the square root of 3 over 2. And so if we plug arc cosine of square root of 3 over 2 into a calculator, then we will have our degree value. And so I'm going to switch back to the browser here. Let's see. Go over here. Browsers, right. There we go. Okay, back to the problem. And so we want arc cosine of square root of 3 over 2. I'm just going to type in the formula like this and click enter. And that is going to be 30 degrees. So what did I type in up here originally? I typed in arc cosine, A-R-C-C-O-S, and then I typed in parentheses square root, or SQRT of 3, square root of 3, space, slash, as in divided by, space, 2, parenthesis. So this is arc cosine of square root of 3 over 2. And then I had to type in degrees, because if I don't, it'll think I'm talking about radians, which we're not, right? We want to know the degree value, the angle, right? And we're saying that arc cosine of square root of 3 over 2 in degrees is 30 degrees. And so the answer here, angle U, is going to be 30 degrees. So this little angle here is 30 degrees. And there you have it, okay? So I think that's where I'm going to stop the video. I think it's kind of long enough, and you guys get the idea, right? If you have sine, you're going to have arc sine. If you're going to get tangent, you're going to have arc tangent, and it's going to operate the same exact way. Set up your ratio, plug it into a calculator, make sure you add in degrees at the end, and you will get the correct answer. Okay? Sounds good. Have a wonderful day. I'll catch you later. Bye-bye.